Today's lesson is all about using double and compound angles by proving identities. So the question will read, prove that this equals that. When you see a sum like that, what is the first thing that you know you should do?
Left-hand side, right-hand side.
Yes, left-hand side, right-hand side. So you immediately split the two sides. You write left-hand side equals the left, right-hand side equals the right. And then you put on your math glasses and you look at the sum. I have a cos 2 theta on top. I want to go to tan. So which of the three possible double angles of cos should I use to go to tan? The one with the sign, because we want sine over cos for tan. So this is what you should think. Alright, so now I need... Pardon? Why don't they? I'm so frustrated. Okay, did your teacher tell you about next week, Thursday and Fridays, half days? Okay. You're still writing on Thursday in the morning. Okay, I'm going to unfreeze. So, the double angle of cos, we decided we're going to use the sine option. And here I have a double angle of sine, which can only be this. So, I multiply the minus into the bracket. These two cancel out, and you're left with this one. But the sine squared is sine times sine. Therefore, I can cancel out those, and I'm left with sine over cos, and that is tan. So you conclude with left-hand side equals right-hand side. The next example, they ask you to prove that this equals that. Immediately you know left-hand side, right-hand side separately. I've got a cos 2a at the bottom. There are three options. Which one should I use if I want that at the end? Cos squared minus sine squared. And this one is the normal sine double angle. Okay. Now, when you have something like this, 1 plus that, This reminds me of the middle term of a trinomial. So the 1 can be split into what?
Square plus cos square.
Yeah, sine squared plus cos squared. The 1 from last year's identity is sine squared plus cos squared. So I just split it so that the middle term is in the middle. Now I have a trinomial. The bottom part is difference of squares. Two brackets, one with a plus, one with a minus. Then you factorize the trinomial. These two brackets can cancel out and you get your right hand side. Very easy. Now let's say you decided to do the right hand side and try to get the left hand side. So this next one is not in your notes. You can copy that. Easy.
Yeah.
This one. The same one.
Yes.
Okay, good. I'm looking at this and I see that I want cos 2a. So this looks sort of like the cos 2a is one possibility. But I have to multiply it with the difference of squares to me to get the cos 2a's cos squared minus sine squared. So what you do at the bottom, you do on top as well, because that will form a 1 and you multiply with 1. Are you with me so far? Mm-hmm. So now I have the difference of squares at the bottom and the trinomial, if you multiply those two brackets, the trinomial on top. These two form 1 and those two form a double cos. These form a double sine. And now you have what you should have on the left hand side. Okay, so it doesn't really matter which side you want to do first. On the memo, we have to make sure that we cover all the options.
So maybe with the one where it can be a quadratic, the squares, and then how do you see that that I should turn it into that?
That you should turn that into this.
Man, anytime when there's you see the top part it's cos squared a plus 2c
Yeah.
when how do you see that it should be like that?
Okay, I don't see from there that it should be this, but it comes from multiplying that bracket with this bracket. Then you get the trinomial if you times them out. Okay. Right. Our next example, if you have a hence sum, it means that you should use the previous one. You had to prove that. Now they say hence, calculate this. Always look at the previous question. This pretty much looked like the same as the right hand side. A is 15 degrees. So this will be equal to that with the 15 degrees. Alright? 2 times 15 gives you 30. 2 times 15 gives you 30. These are special angles. Draw your triangle. Substitute, rationalize, and get your answer. Everybody here? Fine?
In our notes, they said let A equal 15 degrees. You also have to do that, or you just.
No, you can just see it's the same pattern, so that must be equal to that. Now we get to undefined sums. They will give you a trigonometry sum and ask you, when will this be undefined? Now in a normal fraction sum, When will something be undefined?
Zero.
When you divide by 0. So, if the sine 2 theta is 0, so that's one option. But there's another one, tan, because tan has asymptotes. And for the asymptotes, at that specific degrees, tan is undefined. So, you write, you first write tan is undefined for where? For every 90 degrees. And if you add 180, you'll get the next asymptote. If you want add 180, you'll get the next asymptote. Are you on your phone? What are you doing? You should be looking. Am I boring you? No. Okay. The next one is where sine theta is 0. If you have something equal to 0, sine, cos, tan, whatever, always draw your graph. Sine will be 0 at 0 degrees, 180 degrees, and 360 degrees. So we start with 0 degrees. 2 theta is 0 degrees plus k times 360 because we work with tan. These are the general solutions. Then you divide by 2, but remember, if you divide by 2, you must divide every term by 2. So that's why it changes to k times 180 degrees. Or, if it's not 0 degrees, it can be 180 degrees. So if 2 theta is 180 plus k times 360, divide by 2 every term, and then you get that. And this one is the same as the tan one. Therefore, you have to conclude that this sum will be undefined if theta is 90 degrees or 0 degrees plus k times 180. And don't forget your k. Okay. Any questions here? The last example. For which values of a is this sum undefined? Do you see a tan anywhere? Yes. So you start with tan. Tan is undefined for where a is 90 degrees plus k times 180, k element of z. Doesn't matter where tan is, if tan is in the sum, you write that. No. I always start with tan, then I know it's covered. Then you look for the denominators. So it will be where this one is 0 or that one is 0. So it will be where 1 plus tan A is 0, therefore where tan A is negative 1. So you get your reference angle, it's 45 degrees, and you say tan is 0 in those two quadrants, quadrant 2 and 4. So I have two sums, these two. And remember, when we work with tan, it's always k times 180. Now you look at the other denominator. So it's this one, or the first denominator, or the last denominator, where 1 plus sine 2a is 0. There's a 0, therefore I draw the graph. Where is sine negative 1? Only at 270. So 2a is 270 plus k times 360. Divide by 2 all the way through. Now you look at your four final answers. I've got a 90 plus k times 180. There's no one else like that, so that will definitely be a possibility. Or you look at 135, there's another one, so I choose only one. And there's a 315, There's nothing else like that, so that's also a possibility. So those three combined will give me undefined. Any questions? Your test for next week is up until here, at the end of page 33. Okay, your homework for Wednesday is the rest of exercise 5 and the rest of exercise 6, the entire 7 and the entire 8. It's also good practice for the test. We will mark everything on Wednesday. I will start marking now. We'll mark everything on Wednesday and then on Thursday you can start writing. We'll do that after the break, after the school holiday.